Okay, so good afternoon, I guess. So good afternoon, everyone. Uh, so we are here to start the course, which is organized by Cosmic Charade. So this session is about Python. So normally, what happens is that when we study Python, it's like in terms of like programming guys, or maybe you in terms of computer science peoples. So that is not the route we are going to follow. What we are going to follow is about computational thinking. That is how you can devise computation using Python, or not actually Python, rather you can use any language. We have just chosen Python and R because these two are one of the most famous languages. Okay. So I will be teaching you guys Python part, and Samrat the and like Ovirup the will teach you guys the R part. Okay. So today, because it is the first class, so we will not maybe it will be maybe a little bit boring, but today's class will be the core basics. That is what exactly is a virtual environment, how do you set up your Python environment, things like that. So I have shared a video where you can actually like install this Jupyter notebook or Anaconda. So I have actually like shared that video. So you guys can follow that and can install Python, or you can just also like install just Python software globally. Both can work. I will show how both of them, you can use both of them. Okay. Yes.
Yeah, Kazi, I am saying that could you show that how to write codes in Google Colab also? I mean,
Yes,
how to
yes,
use
sure,
Google.
sure.
So, is it possible for you to, I mean, show these things here?
Okay, so I have not actually set up Google Colab. So maybe at the end of the class I can show, because that does not actually take that much time.
Okay. Okay. Sure,
Okay.
sure, sure.
So the
So,
first,
are you
yes,
recording this
yes,
session?
yes, the recording has been started.
Okay.
Okay.
Okay. Sure.
So the
Sure.
first thing which you guys need to know is to install this Anaconda. Why I have chosen this Anaconda is actually very simple, and also it is one of the most important thing in that will be most important thing in our course, which you guys will be seeing why it is the case. But before going into that, let me just briefly tell you guys, why do we even need virtual environment? Okay, so the way to actually understand is pretty simple. So what happens is that, let's say that in this course we have used some sort of packages. Very fine. So we are using packages. So like if you guys know, there is one package called NumPy. We will be coming into that how to use these things. But let's say I have used NumPy and I have written down a code, or maybe some of you guys have written down a code, and let's say that this code which I have written actually needs a version of NumPy which is, let's say, 10.2. Fine. Now you have created a whole lot of programming using this version. Now what you want is that you want to use some other package. Let's say there is one very nice package which is called QM Solver, which we will also learn how to use that. Now this version, this package actually depend upon NumPy, and this NumPy version is actually little bit less than this 10.2. Let's say it actually depends upon NumPy 9.0. So if in your system you have this 10.2 NumPy, then you cannot actually install this package, or you cannot even use this package. This is problem. So that means whenever you are creating some package, you will be like buying separate laptops or maybe some system. No, I mean, that's some rich thing is going on. So what normally we do is very simple. In our one single computer or laptop, whatever you are using, we create some sort of separate compartments. You can think it like that. And inside each compartment, we can independently keep one version of one package. That is, let's say I have created two compartments. I can independently install here NumPy 10.2 and I can do whatever work I want using the package installed in this first compartment. Then you need some other, maybe some other package you want to use, and for that you need some separate version of NumPy. You can independently actually install the separate version in some separate package or some separate block. That is the whole idea of virtual environments. So it is, I mean, it is not like very much needed for our course that you have to like create separate environments. One global environment will be fine. But I will suggest you guys to start this thing from the very beginning. That is, just make it a habit that whenever you are creating some new package, you start doing something new, just create a separate virtual environment where you will keep all the packages related to that project. Okay. And this job can be actually done using many ways. There is actually one package of Python for doing that, but those are a little bit tricky and also use up quite a bit of memory, like we will see. And in this type of cases, Anaconda or normally Miniconda can actually help you quite a bit. Okay, so this is the whole idea of this virtual environment. So if this idea is clear, so okay, so these sessions are somewhat like discussions, right? So if you guys have some questions or some queries, or maybe you guys want to add some points, you guys are welcome. Okay. So this is the idea of virtual environment. So the very beginning is to set up this virtual environment. And like I said, we have used Conda. So now let's see how to set up this virtual environment. Okay, so I am using Linux, as you guys can see. If you guys are using Windows, then in the search you can actually search something called Conda prompt. Okay, so you search that and that will exactly look like this thing. So let me actually close this thing and start from the very new thing. Okay, so this is my terminal. It will be completely blank, just like this. And also okay, so it will look like this, exactly like this. Okay, there will be a base written here and there will be some sort of things going on.
One second, Kaji.
Yes.
Can you please maximize this screen because it is
Oh,
not readable.
oh,
It is
okay.
very small actually. Maximize or just
Is it fine now?
increase the size. Yes, it is fine.
Okay,
Yeah.
so this is the terminal in Ubuntu. It is already there. So now what you need to do, you need to create a virtual environment. So if you are using Conda, there is a very simple way to actually do it. So what you need to write, you need to write Conda, then you need to say create, then you will write n. This n means what is the name of your environment going to be. Then you give a space and write down the name. So maybe my env, my environment. And this is so powerful that you can also write down what version of Python you need to use. It can, in my system, there is 3.12 point something installed, but I can also use 3.9 version of the Python. This is how powerful this Conda environment is. Once I write it down, you just press enter. And what is it going to do? It is going to create a separate block inside my system where I can just write down my code. So it's taking a little bit of time because I just change also my version of Python. Normally it do not take that much time. And it is like creating this environment and it's done.
Kazi,
So
uh,
yes.
yeah, are you showing this for only for Linux,
No, no,
like how
the
to?
same code actually works for also Windows. You just need this Conda prompt. That's the video which I have shared.
Okay, okay.
Okay.
Uh, This Conda form, how do I get that
Okay,
video you
so
have
you go
shared?
to search and you just
Okay,
write down conda, so or maybe anaconda. So there will be like some application coming out and you click it and there will be this black box coming.
uh, uh, okay. Can you assist me on doing this thing?
Okay,
Should I
so
can?
maybe you can share the screen,
Okay.
or one of you guys can share the screen so I
Yeah,
can
I'm
also.
I'm sharing my
Okay.
screen. Yes. Yes. Yes.
Okay, so you have installed conda, right?
Yes, I have this
Okay.
Anaconda
Okay, so now
navigator.
in this search, um, yes, you write anaconda or conda. Okay, yes, anaconda navigator is already there.
Okay.
Oh, yes,
Okay,
this
I
con.
have just.
Okay, no, it's not showing the application. You just like delete it. There was already conda. Okay, so anaconda navigator. You click on that.
Okay. Yeah, it is
It's
already
already open, I think.
Okay, yes, it's already open. So if here what you need to do is you click on environments.
okay. Just go. Go.
Okay, so now
Hmm.
what it is showing you guys is that there are already environments, some environments already given. Now you want to create a new environment. So this is like the whole part which is installed. So you just click on the create thing in the bottom. Yes, now you name the environment.
I will name the environment, but this is okay.
Anything, just don't use any space and number at the beginning, that's all.
Okay.
Okay, so you done that and just create on create, click on create.
Click on create.
Yes.
Or do I need to change
No,
here
no, it's
something?
up to date, so it's fine. We,
Okay, by default. That's
yes.
it. Okay. Right.
So just click on that, and it will create this environment, and also the location is been shown in the down. Okay, uh, it will take a little bit of time.
Okay. 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 In between, you can share your screen.
Okay.
Okay. It's
So
fetching up.
it's already done. It's done. So once the pip is done, it does not take that much time.
Okay.
Oh. Okay, so let me just tell. So once it is done, you just click on this run symbol, which was beside this thing.
Okay. Run means where?
Run means beside the name of this environment, there is a symbol, right?
Okay.
This triangle
This play
symbol.
button symbol.
Yes. Okay.
Okay. Okay. Okay.
So once you click on that, it will just open. The environment will be activated. And once that activated, you can just basically do all the things which I am going to show. And those are only be specific to that particular environment. It will not affect any other package in your system. Okay, so it's done. Now just click on this symbol, the beside the name.
This.
Okay, yes. So just click on that.
Okay.
Okay. So
So
yes, so open terminal, you can just click and then you will get the terminal which I was using. Yes.
okay.
So
Okay.
you get
Okay.
this terminal and see beside this name, there is beside this terminal, there is a name written, right, in the bracket of your environment,
Okay. Okay.
right? This
Okay.
means your environment is been activated.
Okay.
Okay, fine. So now you can just follow along.
Yes. So let me unshare my screen.
Okay, so everyone, I think it's now fine. So if you guys are using actually Linux or maybe a Mac, you don't actually need to do all of these things because it is already installed in your system. Advantages for us. Okay, so this is now my environment, right? So this is my environment has been created, and now you see you just have to remember this command. it will activate your environment. So like in Windows, you can just click on that play button and it will activate your environment. In Ubuntu, you just have to write down the code. So it's conda activate and my env.
Kazi,
Yes.
hello, Kazi, I will suggest that you just maximize your screen. Otherwise,
Okay.
the whole rest of this
Okay. So like
option.
this. Okay. Okay. So I activated my environment, and now you can clearly see that beside this, my environment name is showing, right? This means that now my environment has been activated, and whatever I do now will be specific to this particular environment. It will not affect anything. And if someone is curious, base means that you are on the whole host computer. That is, it is general or global thing you are doing. Okay, so this is my environment now. Once you activate this environment, you can just follow. It does not matter if you are using Ubuntu or Linux. It's actually exactly the same. Okay, fine. So everyone, I hope that it's clear up to this point. So any doubt up to this point? Okay, so I guess everything is fine. Okay, now I will suggest another point which is very specific, because you will be seeing many codes in whole of this internet using pip. So the first thing is that to install any Python package, what you need to do, you need to write down this command. You need to write down conda install and package name, but it does not always work. So because of this thing, I will suggest you guys to just install first conda install pip. Once you install this pip can actually install any package available in the internet. So my pip is already been installed, so it's done. Now you want to install some package. So let me just show you one of these codes to install one package. So let me just install Jupyter Notebook, because that is what we are going to use. So you just basically write pip install Jupyter Notebook, and it will install your Jupyter Notebook in your system. Like you can clearly see, it is installing Jupyter Notebook. Okay, so it is going to take some time, and once it's done, you can actually have Jupyter Notebook in your system. Okay, so let me just stop it, because I already have a virtual environment, and for stopping any process, you just click Control C to stop these things. Okay, so let me
Okay.
just yes.
Yeah. Yeah, sorry to interrupt you.
Okay.
So after conda install pip, then what I need to do?
You
Can
just
you
need
repeat
to
once?
type this pip install Jupyter Notebook, and it will install Jupyter Notebook.
Okay, pip install pip.
Yes, there is a gap between Jupyter and Notebook. Remember that. Okay. I mean, for your case, you actually don't need to do it. I mean, in Windows, there is actually a like a visual thing which will actually show you that you can. Okay. So, I mean, basically, it's done. So, I already have a environment created for this course. So, I will be using that. Okay. So, this is my thing. So, I have this package. So like you can clearly see, I just write conda activate, and the name, you have to remember the name. So the name is here, it has been activated. And after installing Jupyter Notebook, you just have to write Jupyter Notebook to start using it. Just Jupyter Notebook, and you just click enter. And in your Google Chrome or whatever browser you will have, it will open a Jupyter Notebook. So Jupyter Notebook has many versions. Whatever I am using looks like this. Okay. After activating Jupyter Notebook, you can go to new. You can select this notebook. I will suggest initially to just select this notebook. You will select this notebook, and your Jupyter Notebook will look like this. So you can actually select whatever programming language you need. Like in my system, there is Python, Julia, SageMath, and things like that. So I only will be selecting Python. If you have R, it will also show R. You can use any of these things. I will be using Python. So let's select, and now I can write down the Python code here. Okay. So up to this, I hope that it's clear. And if you want to save this Jupyter notebook, you just write the name here, and you can give whatever name you want, like first uh, class, and you just rename it. Now, if you want to save it in a particular location, you go to file. Now you go to this save notebook as. Once you click it, it will show you the file. Now in Ubuntu, you actually already select in which file you start. So this is my file location. So it will be by default creating files in that. Okay. So in Windows, you will get a selection process, and you can select in which file you want to install things or save things. Okay. But let's not focus on these things for now. Today I will be just now covering the basics of Python. So this will be like very like boring thing. Maybe at the very end you will see few visual things, because it is the first class and we have to know like very basic things about Python. So like I will say that for at least today, it's just basically giving a introduction on Python. Okay. So basically, how do you, first let me show how do you write like code. So normally what you do, you can like write any code in this cells, and you just write click shift then enter, and it will run the code like this. Okay. It does not have to be like one line, you can write many lines, it really does not matter. If you want to write commands, you can actually write here a hash and write some commands. Okay. And if you want to write create a very nice visual thing, you actually select this cell and like click on it and go to this thing, and you write here markdown. So here now you can actually use all markdown things, if you guys know.
Fuzzy?
Yes.
Yes, how to write the, can you repeat once more again? I just missed.
Which
This
commands?
markdown.
Okay, so like you suppose I want to like explain that what I am going to do in this Jupyter notebook, right? So you
Okay,
select this cell, and there are few shortcuts. So let me also tell the shortcut. If you want to create a cell above this selected cell, you click
okay,
A. It will create a cell above. Now, after choosing any cell where you want to write down the markdowns or some codes, or not codes, some English things, you select that cell, and then you go to this thing. You go to this and select markdown, and now you can write down you can write markdowns. Okay. Like I can write here title, so one hash means title. I can also like use LaTeX here. So there is another shortcut. If you like just click on the cell and right click on M,
okay.
it will convert it into markdown cell. And you can also like use LaTeX here directly, and it will be like shown like this. Okay. So these are very basic things. We will learn many things as we go along. So I have already created a notebook for today's class. So I will be opening that. So this is the notebook which I have created. Okay. So now let's just start learning Python. Okay. So like you can see this nice things written, this image given, all of these are done using markdown codes. Okay. And you can actually double click on each cell and can see the code. I will share this thing so you guys can later see how these things are created. Okay. So like I said, today we are going to see a very basic introduction to Python. So what is Python? So we all know that Python is a interpreted object oriented high level programming language. Okay. And it has many built-in data structures, and it is also dynamic, and this dynamic part will be very important in our course. Okay. So it's like a programming language. What are the advantages of learning Python over some other programming language? The first thing is that Python is very simple and very easy to use language. It is so easy that even some of you have not learned Python, maybe it is your first time seeing Python, you will hardly need 1 week maybe to just learn the basics. Okay, so this is very easy. And the another thing is it is very free open source thing, not like Mathematica, and it is like compatible with any platform. Okay. The most powerful thing about Python is its object-oriented programming, which we will not cover in this course in much more detail. Maybe at the very end, I will show a little bit of it. Okay, it has a huge number of libraries. So normally we know that Python is very slow. So that is one of these things. So this weaknesses of Python can be countered using the libraries, which we will also see, because these are the things which we use in our laboratories to speed up the processes of calculations. It has many built-in data structures. It has huge applications. You name some famous thing like Google, maybe Facebook, all of these are maybe built using Python. And it has huge community and very supporting community. So it's like you are stuck at something, you can just Google that thing out. You will mostly 99% sure that you are going to get some help. That is how powerful its community is. So this is like basically a little bit of cartoon that this is like Python, and you can actually include many packages to like make it much more powerful. Okay. And so this I have added for a particular reason. The thing is that it's not like you just think that in the very first class you will get something very interesting. Like when we learn physics, you cannot just jump to black hole, how black hole works. You have to start from the very basics, calculus, Newton's laws, differential equations, a little bit of probability, and you can then reach that particular knowledge. So that is what we are basically going to do in this course. Okay. So like my job is to just show you how to build up the things, then you will go much more further. Okay. So as it is the first class, we will not go into much more detail of how these things are, or maybe a little bit historical things. I mean, I myself am a physics student, so I don't like histories. So the best thing what we can do, we will just straight dive into the simplest things in Python, that is the numbers. So in Python, the numbers are normally defined by saying that they are some data types. So these are all the data types which present in Python, which is there by default in Python. So there can be numbers, sequences. There is actually separately sequences, which we can say string, list, tuples, which we will learn. Sets, the set theory sets, which we normally learn in set theory in class maybe 11. There is also a none data type, and there are some mappings. So today what we are going to learn, we are just going to see strings and the numbers. That is our goal for today's class. Okay. So what are strings? So strings are like, you can think it like a bag. So you like have a box or maybe some bag, and you put different alphabets, some Unicode characters inside it. That thing is called a string. Okay. So like, so how do you create a string? So normally, I mean, from our experience, you can just think string as like some alphabet in double quotation, or you can also use single quotation. It really does not matter. Like you can see, same thing. Okay, or maybe I should use. Okay, okay. So now, how do you know that it is a string? So there is a by default function in Python which is type, type. The name tells you all about the thing. You write type, and just inside this bracket you take anything, you put anything, it will tell you what type of object it is in Python. Here I have written type, and in quotation I have written string. So it is giving me output of str, which stands for string. Okay. Again, same thing. So it's not like in Jupyter Notebook you just write one line of code in each cell. You can write multiple, like here I have written it. So print is a function. So in Jupyter Notebook, by default, the output will be shown. You don't have to do anything, but it's only in Jupyter Notebook, not in other language, other applications or softwares. So to show the output, you have to explicitly tell Python that show me the output. For that, I use a function print. And how do I know it is a function? Again, I can actually write type, and inside it I can just write print, and it will tell me that it is a built-in function or method. So this is how type works. So you can actually say that print, and I have written a string cosmic. So when I run this cell, it is going to give me the output cosmic. Okay, and to comment out anything, you just put the cursor there and just you click control and slash, and it will just comment out the line. Okay, and same thing in the reverse also works. So I want to print which type of object this cosmic is. I can run it. So the first output comes from the first line, which is print cosmic, and the second line is saying that it is a string. For the class, we will come back it in some other class, that what is this class. In some other lecture we will cover it, but for now just think it that string is some sort of class. So class is like the big sack, and inside there are multiple things, and this is this str, means string. Okay, so in Python there are many ways to write down these things. You can combine two different strings. So what I can do, you see, you can also save the strings inside a variable. So like I have written a equals to cosmic. This means set the value of this a equals to cosmic. So whenever I write now in any place, I write a. Okay, so a is not defined. I have not run this cell. Now let me run it once again. You see it is showing me cosmic. This means the value of a is now this string cosmic. It's equal to that. B, I have just said it Charade. So now I can individually print, say print a, and it will give me the output cosmic. Okay, what I can do something much more interesting. I can say that print a plus b, and it will give me an output which combines these two strings. If I give here a space, you will see a space. Okay, so okay, okay, so let me run it. Okay, so now there is a space. So space is also considered as a character. Okay, so this is string. You can combine many strings. You can also see what is a plus b's type. It will be string, as we know. So it is showing me string. If you want to like repeat a string multiple number of times, you can use normal algebra. You can see write a into, maybe I want to repeat this thing 3 times. I can do something like this, and it will repeat this thing 3 times. Okay, so basic things with this string. Okay, we will see much more detail of these things when we start the sequence. Just a basic introduction of these things.
I have a question, Rajiv.
Yes.
What will happen if we use oblique operator? I mean a by 3, then what will
Okay,
happen?
so let's see. The best way to is just see it. So each operator is not defined for each, all operators are not defined for each type. So let me just run it.
Okay, okay.
Okay, so it's
Uh,
something like this. It will just say
Unsupported.
that it is unsupported for string.
Okay.
Okay. You can use power. So in Python, the power is double star and 3. So it's also not supported. So only multiplication is supported for strings. Okay.
Okay, got it. Thank you.
Okay. So now I want to, like, you can also play with numbers in the same way. Like I have, let's say 5. So I can save it in some variable, let's say C. So see, here I can define some C at the very beginning. I can say C equals to A plus B. And after doing this, I can actually say C and it will be string. But I can redefine any variable at any point. So I can just redefine it as C equals to 5. So now it is converted into some integer. So now I am printing this C. It will give me the number 5. I can see what is the type of this thing, which is integer, as you guys can see. So it is telling me that it is actually a int type. Okay, well, maybe let's keep things a little bit mysterious so I can actually clear all output. Let's see it once again from the very beginning. Okay, let me just quickly run these things. Okay, so A is not defined because I am defining it at this line. Fine. Okay. Now I am doing C equals to 5.0. So now you see there is a extra 0 point something here. So now this means it is not an integer anymore. It is now converted into float. So first let me run it. So it is showing me 0.5. Now I can like ask what is the type of this C. It will tell me that it is a float type. Okay. There are many other data types here like 2 divided by 5. So it is like a function, a mathematical function here. And we will see it in much more detail. But for now, let's just see what happens if I run it. It gives me 0. So this actually just give me the quotient of any division. So I can like write here 6. So the quotient is going to be 1. So it's giving me 1, or maybe I should write something interesting, 12, so it will give me 2. So it is quotient. So it is giving me like some integer. So I can write print type 2, what is the quotient of this thing. So it is coming out to be integer. So I can run and it will give me integer. Remember, whenever in any programming language, any number just goes back to which is much more general. So if I write down 5.0 here, it is a float. So Python will automatically convert the output into float. We can see it, it's converted into float. Okay. So always Python will go back to which is much more general thing. Okay. I can also write, so there is one keyword argument which is like true or and false, which corresponds to 0 and 1. So I can run this point and these are called booleans or bools. Okay, so write true and false, right or wrong, things like that. In Python, you can also by default define complex numbers. So normally in Python, complex numbers are defined by J, not I, like engineering peoples, and it is normally accessed by this number J. But if you just write down J, it will not work. You have to write some number before that. So let's say I want to define just I. Someone wants to join. Okay, sorry. So I want to write it like this. I want to define J. So it will not show me error because J is not defined, because it is like some alphabet. To access the number, you have to include some number before it. So if you want to define J, you have to write 1J. And it will give me 1J, which is complex number. How do I know it? You multiply it with another 1J. It should give me -1. And it indeed gives us -1. So any complex number, Z, can be defined by 2 plus 3J. Or you can also define it by typing complex 2, 3. It will generate the complex number. And I can run it. You can see first it is printing down the value, this. And after that, it is showing you what is the type, which is complex. You can access the real and imaginary part by writing down z.real or z.imaginary, like this. And you can clearly see that by default, it is converting all of these things into float. Okay. Very important point to remember. Okay, fine. So these are the very brief and quick introduction to these data types, different types of data types. As we go along, we will see these things in much more detail. Okay. Now let's see a few basic arithmetics. Okay. So let's say that I define a equals to 2, b equals to 3, and I want to use it as a calculator, use Python as a calculator. Certainly I can do that. So I can just directly like write down print a plus b, and it will give me the answer. I mean, certainly it can give me the answer, which is fine. But always remember, when you are writing down the code, the output should be readable by a human, not by a machine. So you want to write it down in such a way that people know that what you are doing. So what you can do is you can use the print argument by this way. You can say print, and in double quotation you can write down any string, anything, whatever you want. So I have written print a plus b equals to, and quotation. This ends one part. So let me just show you. If I just write down this part, what it will output. It is printing what is a plus b, just like a string. Now you want to include also the result. So you can just give here a comma, and what else you want to print. You print a plus b. So now if I run it, it will give me a plus b equals to 5. You are calculating a plus b, which is 5. So this is a way to actually make things look a little bit nice. You can also save this a plus b into some variable, maybe c, and then you can say that print a plus b, which is equal to c and whose value is equal to then comma c, and it will certainly print it out. And it's not just this, you can again put a comma and put some other argument, and it will give you that thing also. Okay, you can also, there are many like things like this hyphen n simply means slash n simply means to break the line. You can do it like this. Okay, so it's to just make your output look a little bit nice. So I can do much more interesting things, some basic arithmetics. I can also say print sum is and a plus b, and I can do also the product. Product is a into b, and if I run the thing, they will give me this. But still, this is not telling me what numbers I am using. So there is a way to actually also do that. Okay, so to do that, what we normally do is you say you use a percentage here. So let me first show how you actually use this thing. So let's say I am writing here print. Now in quotation, whatever you write, A, okay, sorry, A and B, it will just print it as it is. It will not use this 2 and 3 values, but I want those values to show when they are printing. I want Python to automatically replace this A and B with their values which are already defined in my code. So for that, there is a way, many ways. I will show you two of these ways which I normally use. So the way to do it is very simple. You just replace this A with percentage S and also this B with percentage S. It simply says that whatever are the values, there are two variables which have some value in Python. I want to convert these values into string and then print it. This S stands for string. And then to access the values, after this closing quotation, you do not give any comma. You just write here a percentage symbol and just give a bracket. And just write down the variable one by one by the order by which you want to replace the strings. So if I run it, you see this first one, for the first one, the value of A is used. For the second one, the value of B is used. So you can automatically just do the thing. Okay, and then you can just give a comma and can write A plus B, and also the value of A plus B will be shown. Okay, so I can just do something like this, A plus B equals to, and then run it. So it is now showing me much more clearly that 2 plus 3 equals to 5. Okay, right? So I hope that it's clear. Okay, so here also I am doing division. So I have written division percentages by percentages is. So I am saying division, so there should be of division of A. That's why I have written in A at the first by this B is, then comma whatever is the division value. If I run it, it will show me this. Okay, very nice, right? So this thing is a little bit more complicated for beginners, so there is actually another way to do it. So this is this way, and let me again show you what it actually means. So now I am using something which is called formatted string. So what it is, so it's exactly the same. Just at the very beginning, you just write here AF, which tells you that it is a formatting string, formatted string. That is, it tells Python that now you have to be very careful when printing this, because inside this there are few parts where I want to replace things with the values saved in Python. So let's say I want to print A and B like we have just done here. So the way to do it is you just do a second bracket and write down the exact name of the variables which you want to print. Okay, so I want to print A. and B, and I run it, and they will just directly give you the answer. Okay, so for this thing is actually much more useful later, but for now maybe this is something which is much more simple for you guys. Okay, so let's see one example here, like I have written. So I have using formatted string, and I am saying taking a to the power of b. So it will automatically say taking 2 to the power of 3 is, then I am using something called pow. Pow is a function which calculates the power in Python. Like you can clearly see here, 2 to the power 2, which will give me 4. Okay, or you can also use 2 to the power 2. So double star also means power, same function. Okay, so here I am using pow. If I run it, you will just see this thing. So these are the ways to actually make your output look a little bit nicer. Okay, so there are some other basic arithmetic going on in Python. So let me show you them one by one. So the first one where you are using, I am using percentage symbol. It is exactly same, I think, for all programming languages. It gives you the remainder. If you divide 5 by 3, it will gives you the remainder. So it should be 2, right? This one, this last one, double division symbol, will give you the quotient, which is 1. So it gives you 1, right? And for the middle one, it gives you the power, like you just see. So it's 8. So 2, 8, and 1. That's normally what we see. Okay, so up to this, any questions, anything you guys want to ask?
Yes, I was asking that for if you are applying if, so if means formatting, so that is means the value you are assigning to the variable.
Exactly. So
That will be the
formatted
okay.
means that you this is a string, right? I mean, it is clearly a string because it is in between two quotations. So what I am saying
Hmm.
is that to Python, I am saying that inside this string, so if I don't write here if, see what happens. Python is taking whole thing as a string, right? The second brackets are also string. If I run it, you see, it's just outputting like this. Okay, so the if actually tells Python that be careful, inside this string there are few parts where I want to use the variable value itself, which is saved in my code. Okay, that's if stands for. Fine.
Yes.
Okay, so anyone, any other things you guys want to ask? Yes, Abiru. Okay, so these are the very basic operations. We will see much more as we go along, but these are the very basic things which we normally need in basic calculations. Okay, now there are some built-in functions in Python. Actually, there are 68 built-in functions. I don't know why they just do not increase it by one. Fine, but there are 68 built-in functions in Python, which we will learn gradually as we go along. But today I am going to just show you a few of these things. Okay. So the first one is type, which we just already seen, right? I mean, we already see what is the type. Okay, so type, so there is a function called bin. So I am writing type, print type. So bin is a function and it is telling me that it is a built-in function. Like we already see, type gives you what is the type of anything inside its argument. Okay, but what is this bin function actually does? So you can clearly see it is written here. Bin actually converts any number to its binary value. So like 4. So what is the binary of 4? So you can do the calculation a little bit and it should be 100, right? So if I run it, it will give me 100. But Python actually is a little bit more careful. So it will include 2 extra bits in the beginning. So let's see. I run it. You will see it's giving me 100. And inside it, at the very beginning, there is 0b. Okay, so for now, b stands for binary. But this 0, this first bit has some reason for there. We will learn it later. But if you want to extract it, you can actually certainly do it by this way. You can just basically write here to this, which we will learn why it works, but for not now. Okay, you can write any number and it will convert it into its binary form. Just first two will not be the number. It starts from the third one. Okay, so this is how you convert any decimal number into binary. So there is another function called hex, which will convert it in hexadecimal, something like that. So there are many functions, but normally this bin is much more used. Okay, so this. Okay, there is another function which is len, or in simply len means length. So remember I said that this thing, all of these things comes under sequence where string is also there. So string is like a box, and these double quotations are the boxes, boundaries, and inside whatever you write is the elements. So as a result, if I want to know how many elements are there inside it, I can write len and any string. It will count how many elements are there inside. I can run it and it is giving me 6 because there are 6 elements. I can also like put here a space. Space is also counted as an element, so it will now become 7, as you can see. Okay, you can also run like anything like this. It's giving me something like this. Now there is some important interesting things going on. What are the interesting thing I am saying? Suppose there is some problem where you want to know after a calculation how many digits are there in a number. Okay, so maybe this is my number. I want to know how many digits are there. You can certainly count it. If I write here len, it will not give me anything. It will give me error. Why? Because it is a single number. What do we even mean by measuring the length? It will give me error. So for this type of applications, there is a way to convert any type of data to another type of data in Python. So the way to do it is very simple. Suppose I have a number like this. I can convert it into string by a simple function which is str, the name of the function. So I am saying Python that okay, so I know this is an integer, but I want to convert this thing into a string. Treat it as a string. Just give a double quotation and do it yourself. So this will convert it into string, right? And then I can basically do len. Okay, so let me just save it in some variable a, and now I measured the length of this variable. It will give me the length, how many digits are there. A very simple thing. It is also useful in some other way. Let's say that I have like some input like this, some string. I want to convert it into like some integer. So int write b. Okay, it will convert it into integer like this.
Hello, sir.
Yes.
Sir, while calculating that length, that space is also being calculated as the length in Cosmic Charade.
Yes, exactly. It's also include this space. So space, so it is very important. Yes, thanks for reminding me. I should write it down. So space
So,
is also counted as a element. Okay, so this is very important. Sometimes we do get some errors due to this space. Like there can be just a space, right? Not here, maybe here. Now Python will show me error because it does not know how to convert this space into integer, right? So it is very important to remember that spaces are characters itself. Okay, so something like this.
okay, sir.
You can also convert it into float, and you can see how easy Python is. You just write down the name of the types. That's the function itself, something like this. Okay, so this E16 means e to the power. Okay, or 10 to the power 16. That is how scientifically we write it down. So Python use that. Okay, so it's like the same example. I want to know how many elements are there, so I convert it in string first. Then I measure the number of elements, so it's 3. I can convert it into string like I just showed you this. Okay, fine. Now up to this it's fine. I mean, I am writing down the whole code here and I am running it. It's working fine. I mean, nothing wrong with this. But I want to make things a little bit more interesting. So let me now go out of this Jupyter notebook and show you some way. Okay, so you guys should have like something where you can write down the code like a notebook and things like that. But if you guys don't have something like that, I will suggest you guys to use something called Sublime Text. Okay, so it's this software. In Windows case, this is the best thing which you can use for writing down the codes. Why I am showing you this, it will be clear. So let's say that I don't want to write down this use this Jupyter notebook. I want to like write conventional programming things. So how do you write it down? So it is very simple. Okay, so let me just start a terminal here, because you can also run things using terminal. So let me also activate this thing. Okay, so now I want to write down code in a normal file, .py file. So you can clearly see these are IPYNB, that is Jupyter Notebook format. I want to write it in Python format. So what you can do, you can write any code editor or any like text editor, anything, it's fine. Okay. So I have VS Studio, but it works for anything. So I am using just some random text editor of Ubuntu. Okay. So and you can write down the code here, any code. So let me write like 2 plus 3, or let me just copy it from here. Maybe I will just write down this thing from here. Let me copy this whole thing here, and I have not defined a and b, so always be careful. Let me write a equals to 3, b equals to 5. Okay, and you save it. When you save it, remember you have to save it in terms of like .py file. So let me write it, and there should be no space. Let me write it test.py, and if I save it, it has been saved here. You can clearly see as a Python file. Now I want to run this code. So in Jupyter Notebook, it was like just shift enter and the code was running, and the output has been shown here. But for large projects, this is not how we do it. For normal projects, for our like if you want to give a talk, this Jupyter Notebook is very fine. You can write down formulas and things like that. But normally that is not how we run the codes. So normally if you want to write down the code, you create this .py file. You write all the codes in this small thing, and then you want to run it. So to run it, also it works for Windows, the same thing. In Windows you have to use something called CMD or command prompt, or this black thing which just like Avirup, when he has run it, there was a command prompt, so you can just write the code at that command prompt, and the code is very simple. You just write down Python and the name of the file. So what is the name of the file? Test. So I write test, and you just hit tab, it will complete it, and just click enter, and you see the output has been shown here. Okay.
I think it also works by tech.py.
What?
I think this is also work
Oh
by
yes, just the file name, right?
yes by tech no by tech.py py.
Oh yes, it certainly works, but not in all versions, like you can clearly see. Pi is see, whenever you are saving some program, like it is running in Ubuntu or maybe in Windows, there is something called path, where you save the location of each software. So in that path, whatever name you save, you have to use that name here. Like in my system, in normally in Ubuntu's, you have to use Python 3. But I have used Python like we normally do in Windows. Why? Because I have saved it by the name Python. Okay. So normally when this .py works, that means that in that system, it is saved as py. Okay. But it is in general not to. By default, it will be saved by Python. Okay. So I hope that it's
Okay,
clear.
right.
Okay. Okay. So no, certainly it also works like this. Why I just showed you this? There is a reason for that. Let's say that I want to create, write something which is interactive. Whoever is like, whoever is running the code, like I have created some software and some guy is running the code. Okay, and that guy has the full freedom of writing down the variables, but I don't want that guy to go inside and change my written code. So he should be interacting with the program through terminal only after running the code. Okay, so how are you going to do that? Okay, so like see, initially what I was doing, try to understand that I was writing a equals to, let's say that my name is I just write down my name. Okay, and I write print A. Fine. I run it. It is giving me my name. It's fine. Okay. You can also make it very nice. My name is, and it will give me my name. Fine. But I have to change things out from by coming inside this code and then writing it down, and it is giving me the output. I don't want that. I want that whenever the code has been is been run, the user just give the input. So is there a way to do it in Python? Certainly we can do that. You just have to say a equals to, or just input equal input. Okay, so you write input. Input is a function which let user input the data. So I say a equals to input. What is your name? Okay, so let me run this. So see, in this case, it is saying what is your name? It is printing this thing, and then it is waiting for the user to give it some input. Once I give this input, what is going to happen? This input is going to be saved inside this variable a, and then it will print this a. So if I run enter, you see it's just working fine. So this is a way so that the user will give the data, not you. Okay, so let me show how it looks like in terminal. So I will just replace this all code with this, and again I will run it, and you see it is saying what is your name. I write my name and enter, and it is printing it out. So this things looks a little bit nicer, right? You can also now use it as a calculator, certainly. Like I have written here b equals to, and I have said that whatever the, so this will give me input, give me the base value. Base means whatever is the number initially you have, like 2 to the power of 3. So 2 is the base, like we know. And I am saying that convert this value, whatever is given by this user, into int. You can also certainly convert it into float. Okay, because I want to calculate the power. So, and then I say that inside C, take the input from the user by asking what is the power, and then calculate this thing out and print it. So I run it. What is the value of the base? Let's say that I want 7. What is the value of the power? Let's say 2.7. It gives me the output by calculating it out. So you see, this is how you can make things interactive. That is how we create softwares using Python. So again, this will now look very nice in terminal also. You can run it. What is the base? 4. What is the power? Maybe 2. It gives you the output. Simple. Okay. Okay. So there are a few more predefined functions like div mod, which actually gives you the remainder and also the quotient together, like this 0 and 2. Okay, you can like change it to 9, then it will be 3 and 0, something like that. If you want to round any fraction to its nearest integer, you can do that by certainly. You can by using the function round. Okay. Now there is another interesting thing. Suppose I want to make this Python, I want to use the Python as a calculator itself. Okay. So like here I am saying in this thing, I am saying Python to calculate the square, the power, right? B to the power C. But I want the user to also control that. How can you do that? So we will see it in much more detail in later classes, but for today, let me just quickly show you. I can do that. Okay. And this eval, whatever I write down inside, it will convert it into a function. So let's say I want to calculate 2 plus 3. So this input will take this 2 plus 3 and convert it into string. Then eval will convert that string into a mathematical code, Python code, and it will give me the output of 5. So if I run enter, it will give me 5. I can again run it. I can like use any Python code here. So maybe 100 divided by 38 really does not, let's see. So it's again give me the output things like that. So this eval is also very powerful when you want to create interactive things. Okay. Another interesting and important function is ABS, which calculates the absolute value. So minus number, it will give you positive. If you give it complex numbers, it will give you the magnitude, things like that. Okay. So up to this, any questions? So I hope that these things are clear. Okay. Okay. So this should be all of these things for the basic Python, but let me also introduce few things, few interesting things to you guys. Okay. So normally, if you like want to use Python as in science, you need some mathematical functions, right? Like a sine, cos, tan, log, things like that, e to the power. But if I just show you guys like 3.141, so pi, if I run it, it will show you that sine is not defined. That means sine function is by default not defined in Python. Normally, this type of functions are defined in MATLAB or maybe Mathematica, Sage Math, also Julia, if you guys have used it. But for older languages like Fortran, C, C++, Python, these things are not actually defined. Pi is even not defined in Python. Okay, so how are you going to use this? So to use these things, you have to use a library. I mean, there are many libraries. The one which you don't have to install, it comes by default with this Python, is this math library. Okay, so how do you use this math library? It's very simple. You say import math, okay, as m. Okay, so this is a very nice practice to do it like this. I will show another way how to do it. So it simply tells you that import math. So there is a library called math inside this computer. So I am saying Python, just go and fetch this library whose name is math. Okay, and just for my use, I will not write down math again and again. Just call it as m. Okay, that is what this line simply means. So the code is import math as m. I run it, and Python in its memory load this package. Now I can use all the mathematical values. Like I can import pi. So every time you have to use it, you have to write m dot pi. So m dot means, so go into that library whose name is m. Whose name is m? Math's name is m, and fetch the constant whose value is pi. I run it, you get the value. I want to calculate cos, run it, you get the value of cos pi. You want to see the value of square root of 2, you run it, you get the value of square root of 2. You can see the value of the pi once again. You can calculate the log function of so if you don't do give anything, by default it will be natural log. But if you want to calculate the thing in some different base, you have to give the base here, like log base 10. Okay. There is also ceil function, the ceiling function, and the floor function. It is n choose c function or n choose r. You also have factorial. You also have GCD, things like that. Now let's come back to this value. Here I am saying calculate the value of tan at the value of pi by 4. What is that value? 1. We know that. Let me run it. It is giving me a value of 0.99999. I mean close to 1, right? But why this happens? This happens because normally machines convert this whole thing into binary and then do the calculations. Because of that, there is always some things of rounding errors going on in case of this programming language, any programming language. Okay, so this is a little bit of problem. So what does it mean? It means if I want to compare, so if you want to compare two values, you do something like this, double equals. So I want to see that if this value is equals to 1. So if it is true, it will give me true. If it is false, gives me false. I run it, it is giving me false. But I know that this value should be 1. Okay, but then why it is giving false? Because Python is calculating it not to be equal to 1, but rather it is 0.99999. This is problematic. So for that reason, there is a function called isClose. This will let you do approximate comparisons. Like there is 3 and there is 2.99999. So it is approximately 3. So if I now run it, it will give me true. I can also do calculations of pure maths. If a number is finite or not, I can certainly do it. Like I can run it, it will give me true. If a number is perfect square, I can calculate, check it by using is square root. Certainly gives me value. You can convert radians into degrees by degree function. Okay, so in Python you can also define infinities, and the way is to define m.inf. It actually defines infinity. So you can also check if a number is infinite or not by using this. Okay, nan is another data type which we will see later. Here I have just included it. Okay, fine. Now you can clearly see that, okay, so these things are nice. I mean, we can do basic maths. That was the whole goal of today's class. Fine. But I mean, I can run it and it's like some sort of rounding error, right? I mean, pi is infinite. Maybe I want to do maths much more carefully. That is, I want to be much more precise. How are you going to do that? For that, there is a package which is very underrated. I mean, I have not seen many people other than who do research works with Python use this package. Many people just use NumPy, SciPy, SymPy, fine, SageMath. But this package is very powerful. It is called MPMath. It is an extension of this math library and it does not come pre-installed. So you have to install it. So to install it, you don't have to go anywhere. You just run inside Jupyter Notebook. You just say pip install mp math and you just run it. You can run packages inside Jupyter Notebook also. So my package is already installed, so it is saying me that it is already installed. So but if it is not installed, it will install it and it will say to restart the kernel. So what you are going to do after installing, you just go here and you will click here, restart kernel. Okay, fine. So once you do that, you can import this also. So I am saying import mp-math as mp. Okay, so it's just, I'm saying just load this mp math library inside the memory, and whenever I say mp, just import that library. That's all. Okay, now in this library there is actually a very nice thing you can do. What you can do is you can say that mp.dps or decimal percentage or something like that, but it simply is related to decimal points. Okay, so it tells you whenever now I am doing the calculation after running this line, Python, you should be very careful. You have to use much more computational power and at least include 50 decimal places, 50 places or digits after the decimal point. Okay, that much precise you have to be now. Okay, so I now run it. Okay, now if I run mp.math, you will see that it is not showing me something like this. Rather, it is showing me pi and 3.14159 and now this symbol. It means that now pi is very long and I can just blindly use it. Okay, I can use its precise value. Okay, but if you want to see the value, how are you going to do it? So it is, I mean, fairly simple. You can just run it like this. Okay, but okay, so let me just show. It's not like this. Okay. But before that, let me also show another way to import libraries. So let's say you don't want to write this mp again and again. So then what you are going to do? You are just going to say from mp math import and star. It will tell Python to load all the functions inside this library at the same time. That is, once I run this code, all the functions of this mp math is already loaded inside the memory of Python. I don't have to now use mp again and again. I can also use that, it's fine, but I don't have to do that. Okay, so let me now show how to use this pi. Now see, I have set this dps value to 100. I mean, you can just also now write dps. It also works because I have imported all functions of this library, and I have written here pi. So if I just run pi, you are going to see the same thing like before, but now I want to see all the digits which I have loaded, that is 100 decimal places. I just write here plus pi, and it will give me 100 decimal places values. It's not just 100. You can just go like be crazy. Okay, not 1000. It cannot load that much. You have to use some different way, but certainly it can do. Why it is not okay? Let me, maybe I have to convert it into string. Okay, fine. But you can certainly see that it can actually do the calculations in much more efficiently now. Okay, maybe I have to use here MP because I have imported this thing previously. Yes. Okay. So this, now there are 1000 digits of pi just showing in your screen. There are another things also like phi. You can also see all the digits of phi. ln2, see, it is calculating precisely up to 1000 digits. Now I am calculating again 10 pi by 4. Now it is giving you 1, right? Now it's correct. And the power of this MP math library is that you can do absolutely crazy things. Like you can calculate functions in complex numbers also. Let me just show here, right? I mean, it's too much crowded. I can just write like I just want to do it for like this many digits. So it's just doing these things. Okay. Gamma function, I can do that. Zeta function, I can do that. Okay. And you know that zeta of 2 is pi square by 6. So yeah, you can also check. You can calculate the zeros of zeta function at some location. So I want to calculate the first non-trivial zero of zeta. Certainly. Real part is half, imaginary part is given. I can also calculate the second one. I can also calculate the 12th. Certainly. You can calculate the Fibonacci numbers. Okay. Now plotting we will come much later, but this MP math library also includes plotting functions. Okay. So for plotting, it's very simple. The basic syntax, if you are using MP library, you just write down the name of the function and then you give for the what range you are going to plot. You just do that. Okay, so okay, so this is giving you the value plot. Very simple. You can take any number like, okay, maybe zeta function. I mean, certainly you can do crazy things. Okay, so you can also plot many functions one at a time. Just you have to do like third bracket and give all the functions. It will give you the plot. Okay, you can also access for physics peoples. There are many physics peoples. You can also calculate Bessel functions. Okay, so for now, let's not be that much careful about these things. We will learn, but you can plot certainly the different Bessel functions. Okay, you can also plot the complex. You can make complex plots of Bessel function. Okay, but complex contour or sorry domain coloring actually needs a little bit of time. Even if I set this decibel place to 7, I mean, it takes a little bit time. So that this is how it looks, the complex Bessel functions diagram. Okay, you have also a function in print where you don't have to like do anything. You just write pi and how many digits you want it to share things. Okay, but it does not work if you just set it like this. You have to load it in the memory first, then you can show it. Okay, you can also calculate the tailored series, right? So what it is calculating. So if you guys are you guys want, so can someone tell me what is the Taylor series of like cos theta? I mean, certainly we know, right? Okay, maybe people are a little bit sleeping. So I mean, we can calculate the cos theta series, right? What is it? It is just 1 then it is x square by 2 and goes on, right? So you can also calculate this thing out in using this thing, right? I mean, if I am more careful, then x to the power 4 by 4 factorial, things like that, right? But I mean, certainly you can also calculate this thing out in Python. How? You can just say the Taylor cos, and you want to like keep the first 5 terms, so 0 to 5, okay, and I want to chop after like going to 5 terms, okay, and I want to print it. So it will do what? It will print the first value. So the first one is the constant 1, the second one is the coefficient of x, which is 0, the third one is the coefficient of x square. You can use anything and it will give you the Taylor expansion of these things. You can also do the Fourier expansion. You can run it and this will give you the coefficient of coses. This will give you the coefficient of sines. We know, right, that for a square wave only sines coefficient are there. If I run only cos, it will only give me the cos value. The sines will all be 0. And that is what we normally see. So these are all the things related to maths which we can just do using basic Python. I have not defined any function up to this particular point. We have not learned loops, anything. If you want to just use Python as a calculator, you are certainly welcome. You can do wonders. But this is not all. We have just touched the tip of the iceberg. So today what we have learned, we have seen what is Python, how to create virtual environment, what are the data types, how do you use Python as a basic calculators and things like that. Okay. So after doing all of this work, we just save this Jupyter notebook by Ctrl S, and you can save it, and you can also export it as a LaTeX file, a PDF. That is actually the best thing for your the reason for using this Jupyter notebook. So you do some calculation, you want to share it, you can just say click on that PDF option and it will just convert your Jupyter notebook into PDF and download the thing in your system locally, and then you can just send that PDF to any person. Okay, so it takes a little bit of time, but it will just automatically convert it in PDF and just download it. Okay, fine. So any questions up to this point? Okay, so you can clearly see it's been downloaded and this is how it looks like. Okay, all plots will be there, everything. Okay, fine. Okay, so any questions? Okay, so I guess
I have a doubt that
yes, please.
for plotting you are using first bracket and then you are using third bracket, like that.
No, 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 no. Okay, so let me see. Uh, it's only like if you are using single thing, you only have to use first plot, then the first brackets. Whenever you are using any Python function, the argument should be inside the first bracket. Like you write f of x, then you write the function, whatever you want to plot, and then the range. For the range, you need to use the third bracket. Okay.
Okay.
Now, if you want to plot many functions, like here I am plotting 3 functions, then you have to use third bracket to give the name of all the functions, right? So I can like do something like this also. Let me say that I am plotting sine, cos, okay, and let me also include tan. It will show a little bit of discontinuity, we see, but discontinuities are like drawn like this, so it is little bit wrong here. I can also say that the points exactly where there is discontinuity, so Python will be much more careful, but we will learn those things later. For now, let's not focus on this. It's just to show you that without even learning Python, you can do basic things like doing some calculations in Python. Okay, fine. So any other questions? Okay, so I guess there are no questions. Okay, so if there are no more questions, then let's just end it here. Okay, so I will share this Jupyter notebook link after uploading it in Google, sorry, in this GitHub, and also I will include one assignment. And for assignment, okay, so I will write it in the group. Let's not take much more time. All I think people are sleepy. So okay, so then if you guys don't have any questions, then this will be all for today.